Cambridge AS Computer Science, Chapter 10, Data Types and Structures. What do we talk? What do we mean about data types? You have several data types in programming. For example, you have integers, you have real numbers, you have text that is called a string. So these are the data types, and some of them are already built in the programming language. However, data structures is something a bit composite. So the data structure is something composite. For example, an array. You should have some knowledge about arrays from the O-level course. Okay, so an array is a data structure. Why? Because an array is a list of elements, maybe 10 or 100 elements of some data types. Okay, so when we talk about structures, data structures, we are talking about arrays. We have simple arrays that are one-dimensional arrays. We may also have more complex arrays, that is two-dimensional arrays. And let us start also, we need to define a new structure called record. This is the new thing we will be teaching today, and this is the main topic of our session today. Okay, however, chapter 10 is about data types and data structures. We will be dealing lots of time with arrays. Okay, okay, let us start from the beginning. Data types. Primitive data types. Primitive data types are data types that are already available in the programming language. Readily available in the programming language. So primitive data types are those variables that can be defined simply by commands built into the programming language. For example, you should be familiar that with integer data types. You should be familiar with real data type. Real data types are numbers with fractions. Integer are whole numbers. And signed means positive and negative. Okay, real is a signed number with a decimal point. Character or char is a simple alphanumeric character. A string is a sequence of alphanumeric characters. Boolean is true or false. Also, we may have date or we may have currency. However, the format of displaying the currency symbol is not available in all programming languages. Okay, so these are primitive data types. Further data types, the string data type is known as a structured data type. So a string may be a series of characters. Then we talk about structured data type. Okay, it is essentially a sequence of characters. Date and currency have various internal representation but are output in a conventional format. Okay, you may also have date, you may also have currency. Okay, so that's the things we already have. Let us start to introduce something new. We have what is called record. We have what is called record data type. Okay, records are user-defined data types. You need to define that record before you declare a variable of that record data type. Here, with primitive data types, you just declare the variable of that data type. You just only need to declare it. Here, you need to define the structure of the record first, and then you declare a variable of that record type. So records are user-defined. We will see examples now, and these have to be user-defined or programmer-defined. You will never find a record built in simply because every programmer will need a record with different data items inside of it, according to the problem being solved. So records are user-defined data types used to hold a set of data of different data types under one identifier. The record type is known as a user-defined data type. And a user here is the programmer. So the record is programmer-defined because the programmer has to decide which variables to include as records. So the programmer has to decide which fields or which variables to include in a record. Okay, so now let us give an example about defining a record structure. You write here type and the name of the new structure you are defining. And you declare the fields and the data types of the various fields inside of that record. So it starts with type and end of type. Inside of it, you declare all the fields belonging to that record. You define fields with their data types. So here, fields here are some primitive data types. So a record is a composite data type that may include two or more of these primitive data types. And then you declare a variable of that record type, and then you use it with the dot notation. Let us give an example to clarify all these formatting things. So you define a record data type, you declare a variable of that newly defined record data type, and then you use the dot notation. You use the dot notation to access individual fields in that record. Let us go into an example, otherwise we will not be able to understand. Okay, so sometimes variables of different data types are a logical group. So, for example, a person. What fields or what pieces of information we would like to group together about one person? For example, a person has a name. A person has a date of birth. A person has a height. A person has a number of siblings. A person may have something like he is a full-time student, yes or no. So as you can see, several data types, several data items about one person. I would like to group these together under one record. This is what we are aiming for. Okay? So we have the name is a string, date of birth is date, height is real, number of siblings is integer. Let us go directly into the example. You define the record structure first. So you write here type, and this is end of type. And here the name of the newly defined record. The newly defined record will be, for example, called person type. And inside that newly defined record, you will have a name, and that name is going to be string. You will have a date of birth, and that date of birth will be a date. You will have height, and that height will be real. You will have number of siblings, and that's gonna be integer. You will have is full-time student, and this gonna be Boolean, for example. So you define first the record, and then you declare a variable of that record. So now you declare person of data type person type. Then you inherit, and I mean to use that word. Then person, that variable, inherits all the properties here. When you declare a variable of that data type, that variable inherits all the properties in that person data type. Now person will have person dot name. See that dot notation? So because person of that data type, and that data type has a name, so now person dot name. You can assign Fred to person dot name, because name is one field inside of the data type person type, and person is of type person type. So now it inherits dot name, and you put Fred in it, dot number of siblings, and you put 3 in it, dot is full time, and then you put true in it. So you use the dot notation to access individual fields inside that record. Okay? And for example, to output a field of a record, you output person dot what field? Because person is already composite now. Person of data is of data type person type, and person type is composite because it's a record. So you cannot just output person. No, you have to specify what field inside that person, and then you use the dot notation. Okay, the dot notation is very popular in object-oriented programming, and learning about defining records is one step towards learning object-oriented programming. Object-oriented programming is such a modern and big topic. However, you don't need to study it right now. You need to study it, inshallah, in the A2 in paper 4 with programming. Okay, so what are the advantages of using records? Okay, maybe probably that is an answer to a question in the past paper. A advantage of using data record is that set of data containing all data related to one customer of different types is held under a single identifier. So you can collect several fields of different data types and hold it under one name that is, for example, person, and then person will have dot name, person dot number of sibling or so. Okay, let's go to another example. We would like to study as much examples as we could. Okay, a car manufacturer and seller wants to store details about cars. These details can be stored in a record structure. Yes, we are here to study record structures. So type car record, and we declare inside of it vehicle ID, which is a string. And you may put comments. These double slash indicate that the following is a comment. Okay, so it has a vehicle ID, and this is of data type string. It has a registration. It has a date of registration, that's of data type date. It has engine size, this is integer. There it has purchase price, and this is of data type currency. Okay, so now you have defined the record. Next, you declare a variable of that record type. So now I have a variable called this car, and it is a variable of that record using declaration. You declare this car of data type car record. Then it inherits. It inherits all the characteristics here, all the properties here. It inherits dot vehicle ID. So now you have the dot notation again. So this car dot purchase price, because it has a purchase price. This car dot, so you can assign 335,000 to this car dot purchase price, or you may print this car dot purchase price. You may access individual fields inside of the record using the dot notation. Okay, then let us move one step further. We can declare an array, for example, with 100 elements. Every element of them is of car record type. Then we have a table. The problem now in this syllabus, I haven't introduced arrays yet. However, because I am teaching AS, you should have some knowledge about O level. You should be familiar with what an array is. Okay? So now I define an array of 100 elements. Every element of them is of type car record. So you have 100 records like this. Actually, you are about to create a table, just like a database. So you have records, and every record is a row, and then you have an array of those records. So you have many rows. Looks like a table in a database. Okay? So declare car. It's an array of 1 to 100 elements. Every element is of type car record. So every single element of these has 4 fields, 5 fields inside of them. Okay? Let us go through examples here as much as possible. Definitely, these examples are real exam questions from the past paper. A company keeps detail of its product items in a one-dimensional array called stock. So we have an array and it's one-dimensional and it's called the stock. The array consists of 1,000 elements of type stock item. So you have 1,000 elements. Every element is stock item, and that stock item is a record, just like what we have been saying here. The record field of a stock item are these. So product code, and this is typical value. We can infer from the typical value that the product code will have data type string. Okay, the price 102.76. We can infer from this that is gonna of data type real. Number in stock 15, we can infer that is gonna be integer. So the declaration to declare that record type, you write here type stock item. Now you are defining the record itself. So you write here type stock item, type and end of type. And you declare product string as discussed, declare price real as discussed earlier, declare number in stock integer as discussed earlier. Now you have created the record. Then you declare the array. So you declare stock, this is the name of the array, colon array 1 to 1,000. So that array has 1,000 elements. And every element of them is of data type stock item. And every element of these is a record. Every element of these is a record. Okay, let us play a little bit. This example is a very simple example. Using pseudocode to modify the values of element 20 in the array. So we need to go first to element number 20 in the array, and then use the dot notation to go to dot price or to go to dot number in stock. Okay, so I would like to set the price of element number 20 to 105.99. Okay, so stock, this is the name of the array. Between bracket 20, this is the index or the location inside the array. Dot price, because every element is a record. So you go to the price field with the dot notation, and then you assign to it the value 105.99. Okay, so first you access the correct element in the array, and then and that element is a record, and then you access the field, the specific field inside that record using the dot notation, and then you assign it 105.99. And the next thing is that you need to increase the number in stock by 12. It is like total, it becomes total plus 12. Or number in stock becomes number in stock plus 12. So here you have a stock between bracket 20 dot number in stock become the old stock between bracket 20 dot number in stock plus 12. Okay, so you just need to increment. So the new value is the old value plus 12. It is like total equals total plus 12, or count equal count plus 12. However, that count here is an element inside an array with records, so you use the dot notation to access that particular element. Okay? Okay. Using pseudocode to output the information for each stock item that has a price of at least 100, and output this information formatted as follows. Actually, you may notice that what I'm having here is an answer to a question in the past paper. Follow this, and then I will refer you to some exercises in the past paper in the classified textbook so that you can practice. I have an array of 1000 elements. I will create a loop to span the whole array from the very beginning till the end. We call this linear search. Okay, so for index 1 to 1000 and next index, this is a for loop. You should be familiar with loops from the O level or from studying chapter 9. So this is a loop that spans the whole array for index equal 1 to 1000. So first starting with index number 1, next index number 2, next 3, 4, 5 until 1000. It is like you're checking every single element in that array. Looking for what? Looking for dot price. See here the dot notation. Looking for dot price. So stock is the name of the array. Between bracket index, that index will take from 1 to 1000. Searching for dot price greater than 100. Yeah, this is a price of at least 100. The price is stored in the field price. Okay, so if stock between bracket index dot price is greater than 100, then output the details. What is that details? The text product code, and then comes the product code from the array, followed by a space and a string or text that say number in stock, followed by the value in that number in stock. Okay, I would like you to be familiar with this. I will color this in green. So print or output, they are the same. This, output this. Okay, it will show this. This is concatenate. When you join two strings or two sentences together, you use that symbol, and it is mentioned in the insert that this is the concatenate symbol. What is meant by concatenation? You join two strings together. So this string goes in here, and you attach to it the stock item.index.product code. So this is the data for that item from the array, from the record. And another concatenate and space number in stock colon space. Let us color this in green because this is the corresponding output. And then that 15 comes from concatenate number in stock. So that was an answer to an AS question. They are asking you about how to deal with records and an array of that records. I think it's so simple. Okay, let us go for another exercise. Here we talk about arrays. Okay, let us now refer to the classified and see how can we solve some examples about declaring a record, creating a record, declaring a variable or an array of that record, and then dealing with it in some way. Let us skip this for a moment. Let us skip this example for a moment. Let us take it from here. This question is taken from 21 November paper 22, which means it is very recent. I pay close attention to recent questions because they will look much like my final exam, or my exam will look much like those examples. You know, there is a syllabus change. There has been a syllabus change in 2021. So anything after 2021 is recent and up to date. Okay, a programmer is writing a program to help manage clubs in a school. Data will be stored about each student in a school, and each student may join up to 3 clubs. So this is the record structure about a student. This is the programmer has started to define the fields that will need to be needed as shown in the following table. So the data will be held in a record structure of type student. So first we will define the record structure of a student. So it will have student ID field of data type string. Unique, which means it's a primary key. You can use it in searching. Email is also string, contain letters number. This will help you decide that you take it as a string data type. Club 1, this is any value in range 1 to 99. Club 2, this is any value in range 1 to 99. Club 3, because he may join one club, another club, a third club. So you have 3 fields for the IDs of 3 clubs he may join. Okay, write pseudocode to declare the record structure for student type. Okay, give yourself some time and write the answer. So you are supposed to write this. Type student, because the name of the record is already decided in the exam. And then declare student ID colon and string. Declare email colon string. Declare club underscore 1, this is integer. Club underscore 2 integer. Club underscore 3 integer. Okay, and then you can earn 3 marks. One-dimensional array membership. Then you need to declare an array called membership containing 3,000 elements. So co-array 1 to 3,000. To store student data. So every element of that array will be of a record structure like this. Okay, write the declaration. Write the declaration of that one-dimensional array. So you should write declare membership. This is the name of the array as given in the exam. Colon array. So now we know that it's an array. Between square brackets, this is the lower bound and this is the upper bound. Your array starts from 1 and ends 3,000. You may say also starting from 0 and ending 2,999. However, that would be more complex. If you have the freedom, make it from 1 to 3,000. It's okay. Of every element is of student type. Every underlined phrase is one mark. So this is worth 1 mark, and this is worth another. This is for the examiner, not for you, but I would like you to know how they mark. Some of the elements of the array will be unused. Give an appropriate way of indicating an unused element. We assign a quotation. For example, we assign for the student ID field an empty string. We assign for the student ID field an empty string because the student ID is the primary key, and for normal data, it cannot be left empty. So if it is empty, then it indicates that there is no data. So you may write, assign an empty string to the student ID field or the email field, or put something out of range in the club field. But this is confusing. This is the best answer. Assign an empty string of the student ID. Some students are members of less than 3 clubs. One way of indicating an unused club field. Put a 0 in it, for example. So club number ranges from 1 to 999. I'm sorry, from 1 to 99. So if he is not a member, because you have 3 fields, field 1, field 2, field 3. If he is member of only one club, put a real value in field 1, club underscore 1, and in the other two, put zeros, for example. Put anything outside the normal range to indicate that he is not a member. Okay? Students are member of less than 3 clubs. So unused fields, maybe this will be unused, maybe this will be unused, maybe the 3 of them are unused. He is not member of any. Then put here 0, put here 0, put here 0, because normal values range from 1 to 99. Okay. Now you have to write a small program that is worth 7 marks. You need to write a procedure. So a procedure has a header. So you write procedure. Okay, let me show a bit of the code. Okay, so you write procedure, and this is the name of the procedure. Okay, and at the very end, you write end procedure, all capitals. Okay, so a procedure get IDs will prompt and input the number of a club. So it will run a code and it first print output, please enter club ID, and then it accepts from the user a club ID and puts it in a variable or so. So let us look at this. Let us look at this. So output, please input club number and input this club, or call it anything you like, but here the variable is called this club. And also remember to declare all variables necessary in that procedure. And these variables will be called local variables because they are declared inside that procedure. So you use this club, so declare this club as integer. Also, you may use index and count as integer. We will see how we will use them. Okay, so it will ask for a club number, and then it will search for all students who are member of that club. So it will output the student ID. So it will do a linear search, spanning the array from the beginning till the end, looking for a match for the club ID given. However, remember, the club ID given you are looking for may be in the club_1 field, or club_2 field, or club_3 field. And you know how to write an array, and you know how to write a loop, and how to use the dot notation to reach individual fields inside of the record that is inside of the array. Okay, so we need to output the student ID of all students who are member of that club. Also, we also want to count the number of students in the given club. Maybe that's why you have a variable called count here that will count how many students are member of that club. And also you may have index, and that index will be the loop counter. So count equals 0. This is the initial value for a variable called count that will count how many students are member of that club. And for index equal 1 to 3000, you should be very familiar with loops, because the array, you travel through the array from the beginning till the end using a loop, probably a for loop. So index in the first round will have a value of 1. Next, in the second round, will have a value of 2, 3, 4, up to 3000. And then you do if membership, this is the name of the array, between bracket index starting from 1, dot club, see the dot notation, dot club 1 is equal to this club ID, the one you input, the one you are looking for, or dot club 2 is equal to this club, or dot club 3 is equal to this club. So you are searching for a match in one of the 3 fields. Then you increment count plus 1, and you output dot student ID, the student ID of that particular student. And then end if. And then for comes with next. Don't forget that the end you have end procedure. However, before end procedure, you have to output the value of count with appropriate text message. So, for example, there are maybe, like, for example, 20 space students in the club. So this is a very kind a programming question. Maybe simpler than the codes we used to go through in chapter 9. However, in chapter 9, I used to ask you to do tracing, dry running, converting a flow chart into a pseudocode, or the opposite. So this is your first code you need to write explicitly from the beginning. This is a procedure. Please give yourself time to copy it, understand it, learn it. Okay, so please get ready to write codes that simple or that difficult, the way you consider. Okay, so please do the next one. Do the next one on your own. So maybe it's just the same with another search, Oh, maybe this is already done. This is already done in my notes. We already did that. Okay, do the one after. Okay, do the one after. And for example, here, absentees. Okay, employee number. Maybe it's another search. So the idea here is that you create a record, you create an array of that record, and then you search somehow. Also count vowels. Okay? Maybe attempt. Please attempt up till here. And that one about check skid will be our topic of discussion next session, inshallah. Thank you very much for your attention.